Okay, our last solving equations lesson, we had things like this. We had the sine of theta is equal to 1/2, and we went through the principal root, we went through from 0 to 2 pi, and we did all real answers. And so your answers here, the principal root for 1/2 is going to be pi over 6, pi over 6 for this guy, and 5 pi over 6. And for all values, this is just a recap, plus 2 pi k, and 5 pi over 6 plus 2 pi k. Okay, so now that's all nice. And we also, if you remember, we did a problem. I'm just going to make it really easy here. We did a problem of sine of 2 theta is equal to 1, and we had, what we had is an a value, didn't we? We had an a value here, and we needed to divide by that a value and go forward. Now, some of you guys are like, whoa, a value? Let me just show you this. 2 sine of theta minus 1 is equal to 0. So what I'm talking about is, let's go back to when we were graphing these things. We had a sine of b x minus c plus d. Remember when we were graphing those? So what I'm talking about is we had this a value, okay? We have a scalar, and we also had a d value. This would be the d value here, right? Plus or minus, moving it up or down. And so we have talked about those too. Today's lesson is to talk about, well, what about if we have a b value that affects our period length? How does it affect our answers? Okay, so maybe that made sense, maybe it didn't. Well, let's just go ahead and start an example if we can, because unfortunately you can't ask me a question right now. So if I said the sine of 2 theta is equal to 1/2, okay? These two problems look almost exactly the same, but they're very different in the fact that the sine of theta and the sine of 2 theta are two different graphs. So let's make sure you understand here. The sine of theta, so the sine of theta, if I were to graph that, would look something like this. It would be out here at 2 pi, would be a full cycle, and we would go up, and we'd go down, and we come back through. And I want to know, if I zoom in on this, I want to know when's it equal to 1/2, okay? And this value right here is pi over 6, and this value right here is 5 pi over 6. And that's how we got those values. But the graph of, let's see if I can get this on the same graph. So we got y equals the sine of 2 theta. That actually means our period length is half as much because we're going twice as fast. Oops, zoomed out here, look, there we go. So this right here, sine of 2 theta, means that my period length is actually now pi. So if I go like this, I'm gonna zoom in way far, okay? So I'm just gonna work on this. So I'm graphing sine of 2 theta. So that means I am done here at the sine. So I would go up, down, and through, right? So that's one period length. But the key is I'm not all the way to 2 theta. So you can see that I would have a whole nother cycle right there. And if you can muddle through this, do you see how there would be, see, I'm zoomed in as far as I can, but there would be one answer there, one answer there, one here, and then one there. So there would actually be 4 answers. So a good rule of thumb, just so you guys know, is that if this is 1, remember what I talked about, so the b value here is 1, there's a maximum of 2 answers. But if I put 2, that means I have twice as many cycles, so I'm gonna have twice as many answers, right? 2 green cycles here, so I'm gonna have twice as many answers. Okay, so how do you solve them? That's the key. So what I do, this is just my technique, and there's other techniques out there, is I say to myself, okay, ignore the 2 theta. And I say, so 2 theta, and I say, when is the sine equal to 1/2? Well, we know it's equal at pi over 6 and at 5 pi over 6. All right. So, but I need twice as many answers. So you need to keep going and figure out what are those values. So what I mean by that is that you just add 2 pi. See, adding 2 pi gives you your second rotation. So trust me here. So from here, if I add 2 pi, I would get 13 pi over 6. Now, how did I do that so fast? In my head, I said that 2 pi was actually equal to 12 pi over 6. And the reason why I chose the denominator of 6 is so I could add it, because this denominator is also 6. And then if I take this guy and I add 2 pi to him, I would get 17 pi over 6. Okay? So what I did was I went one rotation, is the first two answers, and then a second rotation for this right here. Okay? I know I'm going to have potentially twice as many answers. But right now I've solved for 2 theta. I need theta. So what I end up doing is I'm going to do this in green, I think. Divide every one of these answers by 2, and you're going to have all your values. And so this becomes theta, and this becomes pi over 12. Remember the doubling the denominator piece that I've been trying to teach you all year. 13 pi over 12, and then 17 pi over 12. Okay, if I had gone one more rotation, so in other words, add 2 pi to this first answer. If I had written out that one, I would have had 25 pi over 6, okay, because I'm just adding 12 pi over 6. So that, when I divide that one by 2, you can see this one's going to be outside the range because it's going to be 25 pi over 12, and that is greater than 2 pi, so we definitely want to stop at that stage. So this is probably a little confusing for you, but let me just try to explain it a little bit more, is that ignore the 2 theta. Okay, get your answers for when is the sine equal to a half. Okay, those are those 2 values right there. But because there is a 2 theta, write down twice as many answers, because you're going to end up dividing by 2 theta. So for instance, if I were to sketch that on, an idea is that your normal graph, let's see, I'm just going to go to a new paper here. Your normal graph goes from 0 to 2 pi. But what you're doing is you're taking that and squishing it down, and so your graph is actually now that. And so we need to do 2 cycles of answers, and that's why we get our 4 answers. And the last answer I showed you was, well, what about if we go up a little bit more and our next intersection point is past that 2 pi? Okay, so it's a little bit confusing. This is where you guys are going to want to ask questions in Zoom helps, etc. Okay, now those are your answers for 0 to 2 pi. Okay, but what about if I asked you for the principal answer would be easy, pi over 12. And for all reals, don't be scared of it. Just take your first 2 answers. So it's pi over 12, okay, and 5 pi over 12. And then what is this distance now? Well, you also divided, and this is what a lot of kids don't understand, is you actually divided everything here by 2. So you actually took the period and divided it by 2 also. So this distance right here, I don't know if you even realize it, is equal to pi. Do you see how this is? If you were to subtract those, you'd get 13 minus 1, which is 12. So it'd be 12 pi over 12, which is 1 pi. And so you also know that the period length of 2 theta, sine of 2 theta, is pi. The period length is pi. So now this is going to be pi k plus pi k. And so you should see that this answer here is also pi. Okay? The most common wrong answer is to have still 2 pi k and 2 pi k. But this is the period length of your function. Okay? The period length of your function.